Thank you all for coming tonight to my NEU talk on the replication crisis in science. Science and the scientific community have long been what we depend on to determine what is true. Science tests and attempts to answer questions about the world around us, making it an integral part of our society and the way that we function. However, as of recent, there's been a public crisis in confidence in the scientific community. It's been discovered that many published scientific studies and their results are actually unreplicable and untrue. This means that these results are either misleading or false. This crisis has been aptly named the replication crisis. To explore this crisis and its consequences more, we're going to first break down what it means to be unreplicable, unreproducible, and why replication is so important to science. Replicability is the chance that an independent experiment targeting the same scientific result will produce the same consistent result. Reproducibility is the ability to recompute data analytic results giving an observed data set and knowledge of the data analysis pipeline. We will look at the connection between reproducibility and the replication crisis a little bit later during this talk. So then, why is replication even important to science? We know that as a part of the scientific method, a result that has been proven to be true by many scientists is much more strong than a result that has only been proven by one scientist. So, replication of scientific results that ensures that results reported are in fact true instead of being some fluke in method or a mistake made by one scientist. So if replication is so vital for the scientific method, why are so many of these scientific results found to be unreplicable and unreproducible? There are two major pressures on scientists and researchers that have been found to be the biggest contributors to the replication crisis. Research pressures and publication pressures. This first pressure is on statistical researchers and mathematicians to produce results that are significant that will either get attention or confirm a predetermined result. This pressure often compromises their individual research practices, leading to a manipulation of data in a number of ways. For statisticians, the most common manipulation of data occurs during p-value testing, a pretty common statistical technique used to determine oftentimes the probability of certain studies. In statistical tests of data, the p-value is a number that gives you the probability that a result that was found by chance. So if an analysis of a study gives results that have an accompanying low p-value, it's considered to be more accurate. The lower the p-value, the better. So yes, keep calm and drop it low, the p-value that is. Unfortunately, it's far too easy to manipulate this value through design of the experiment. Another way in which data statisticians can manipulate their results is through effect sizes. An effect size of an experiment measures the effect or results of the study in comparison to the population sampled for the study. It's standard in scientific studies to take a large, unbiased population, as it gives a better look at how the study would fare in comparison to the general population. In taking a small, often biased population to test, the desired effect on the population will be seen as more intense or more significant when in actuality, in comparison to a large unbiased population, it's not that significant. Manipulating an effect size would be like researching what % of the male population owns salmon-colored shorts, but you take your population sample as only Northeastern fraternity brothers, so of course, your results find that all men own salmon shorts, and probably multiple pairs of them. So the takeaway here is that a researcher can control the results of their own study by taking a relatively small population size that they know is biased towards a specific result. Although there are cases where statistical researchers have unknowingly manipulated the results of a study, often the researchers are fully aware of what they're doing and that they're engineering the results instead of impartially testing them. Part of the explanation for why studies are so often manipulated is because of the second publication pressures on researchers and scientists. The replication crisis is furthered in a more institutional way by this current publishing system and its biases. Arguably, the main cause of the replication crisis is the practice in the scientific community to either publish or perish. In order to have a career in research, scientists need to get funding and need to be published. This puts immense pressures on researchers to commit academic crimes, like the ones we talked about in manipulating data results. This mentality to give in to what publishers want, or else, can be modeled by a number of underlying social structures that publishers use to pressure researchers. Publication bias and authority bias are two of these social pressures that contribute to unreplicable results. Publication bias is the phenomenon in which experiments in the academic community are far more likely to be published if they have a desirable result, such as ones that are statistically significant or positive. In the publishing community, the outcome of a study actually can determine if that study is published at all. If a result is exciting or about some hot button topic, it's much more likely to be published than one that may be more high quality but uninteresting to the general public. So a study that claims to have found that elephants think humans are cute the way we think puppies are cute will get much more publication and therefore public attention than a supposedly uninteresting healthcare study showing that a low dose of a certain kind of drug doesn't work on certain patients. Although it's sad to eventually find that elephants don't think we're cute, upon more inspection into this study, it's been proven to be untrue. Yet its exciting nature is part of the reason why it was pushed to the forefront of publishing in the most recent months. When exciting studies like this are published, the results are not even questioned or tried to be replicated because of authority bias within the publication community. Authority bias is a condition on which esteemed publication journals and well-known researchers in their field enjoy a level of privilege with what they put out. The results of a published study by a highly regarded scientist are often taken as fact because of the position that they hold in that community. If their results are published by a journal that is held in high regard in the scientific community, the same goes for them. The competition to be highly regarded in a discipline gives those already at the top a right to publish their results without question, which dismisses others trying to replicate their work and check it. This kind of authority bias within publishing can easily be demonstrated by this talk itself. Because I'm dressed well and wearing these glasses that honestly I don't even need to see, you're more likely to believe what I'm saying and what I'm telling you through this talk. If I were to give this same talk while wearing a sweatsuit, it's less likely that you would take what I'm saying seriously. If there are so many factors playing to why the replication crisis is happening, are there any possible solutions that can effectively target each of these contributors? In terms of individual research practices, a popular option is to curb statistical manipulation and to allow for open and honest data. What this means is that when a researcher is analyzing data for a study, the data itself and the exact process that they take to analyze the data will be published itself along with the research findings. This open and honest data approach allows for other researchers to easily double check the work and make sure that it's not biased. In data, honesty is the best policy. Although having open and honest data available may help to stop some of the unreplicable studies at their source, pressures and issues in publication are more of an institutional problem. So to solve this, we must reevaluate the process of replicating studies itself, encouraging and rewarding researchers that are trying to replicate studies or that are trying to publish classically uninteresting studies. In order to actually encourage this institutional change, we as observers to the scientific community also need to reevaluate what we find important about science. The need for science to prove that things are true is something that we've always found important, but if what they're proving to be true is a misleading and oftentimes manipulated result, then that's not actually important to us. If the system encourages unreplicable and untrue results just to feed our own curiosities about science, then we as observers have a responsibility to shift the focus towards an attempt to replicate studies that have already been published, but to also encourage new research to be unbiased in the pursuit of true and honest answers. Thank you, and I hope you enjoyed this NEU talk.